everyone. Welcome to A Moment of Science, Please. My name is Ellis, and I will be your host for today's episode. A Moment of Science, Please is a student-run podcast group based at the University of Toronto. Our goal is to highlight some of the fascinating scientific research we have going on here. Today, we'd like to welcome Dr. David Jenkins, a professor of the Department of Nutritional Sciences. Welcome, Dr. Jenkins.
Thank you.
So to start off, if you could please introduce yourself and tell the audience a little bit more about your background and education.
Well, my name, as you just said, thank you, is David Jenkins. I'm a professor of nutritional sciences. I'm a professor of medicine here at the Faculty of Medicine at the University of Toronto. And I'm also a physician and director of the Risk Factor Modification Centre at St Michael's Hospital, again, one of the university hospitals in Toronto. I was educated at Oxford, where I took my basic degrees in physiology and medicine and did my more advanced degrees too. But I did my clinical training at the Middlesex Hospital. And I did my research training, interestingly, in gastroenterology. At that time, the Medical Research Council, I joined the Medical Research Council unit and at Central Middlesex Hospital. And Dr. Dennis Burkitt, who was one of the gurus of dietary fiber in the old days, his ideas were taken up by the Medical Research Council, and I started work in that particular area, obviously of great interest for the gastrointestinal tract, but I was also allowed to look at its metabolic effects, things like fiber and diabetes, fiber and cholesterol, fiber and heart disease. So these became my particular interests. I then returned to Oxford to Richard Doll's department, Richard Doll of smoking fame, cigarettes and smoking, cancer. And I worked with him and also in the physiology department. I developed my interests in basically what the health implications were of the sorts of foods we were eating. I came to Toronto and so I was just invited to take a position in the Nutritional Sciences department with a cross appointment to Toronto General Hospital and St Michael's Hospital. I ended up making the focus at St Michael's Hospital because there was a big interest there with Dr. Little in lipids and heart disease in those days, and also in diet. He was interested in diet too. And so I worked with him in the lipid clinic and did also research on patient groups, feeding them different sorts of diets and different sorts of fiber, and looking at cholesterol metabolism and these sorts of things. So that was interesting. And at the same time, before I'd left Oxford, we were quite concerned that we didn't know quite what fiber was doing in the gut. And that was my relationship with gastroenterology. And so we looked at gastric emptying, and I thought, well, one of the good things that you can use to see whether your stomach is emptying is look at the blood glucose rise that you would expect to take place after absorption. So if your stomach released glucose slowly, you'd get a flat rise, and if it released it quickly, you'd get a big rise as soon as the glucose went into the small intestine. And we noticed that fiber was very strange because it would flatten the rise. Not only did we not get a rise delayed, but it just kept things flat. So we thought this is very interesting. So fiber obviously may have some physiological connection with diabetes. There was an epidemiological connection with diabetes. People who ate high fiber diets tended not to get diabetes. That's what we know. But then this started giving us some ideas of what the mechanism was. So after a while, I think our group realized that it wasn't just the fiber, it was many other things in the food that also delayed its absorption pattern. So if not all carbohydrate is going to be absorbed in the same way, then we really ought to index it. So things that cause foods that cause a high rise for the given amount of carbohydrate will be called high rise foods, and then low rise foods for those that just cause a flattening in the absorption pattern. And so we thought, well, let's make an index out of it and call it glycemic index. And so we started working on that and calling it glycemic index, testing a lot of foods and coming out with a food table that gave the glycemic index values, the degree to which a food raised the blood glucose by comparison with the degree to which glucose raised the blood glucose. So if you gave a person glucose or the same amount of carbohydrate as the food, what was the ratio? So was it sort of 20% of the glucose rise, 50%, 60%, depending on what the food was? And I then later standardized it against bread, because when I talk to patients about, well, if this gives you half the rise of glucose, well, they say, well, I never eat glucose. So, so one realized that one wasn't making a lot of impact. So I said, well, what about bread? So we then expressed it as the degree to which 50 grams of carbohydrate in white bread would raise the blood glucose. And that makes it more sensible, you can understand. So if I say that pasta is 50% of bread, then it means something to people. If I say that beans may only rise 30% of bread, then that means that makes sense. So that became our glycemic index standard. So we were working then on two things. We were working on fiber and cholesterol and lipids and that sort of thing, and also on carbohydrate and its effects on diabetes, the postprandial rise, its effect on diabetes. And we worked on drugs too that did this. Acarbose, for example, which is a drug that inhibits glucose digestion or reduces the rate of glucose digestion. Did the same thing. It converted the whole diet into a low glycemic index diet, and that was useful to work with too. So the work of my life has been just related to these sort of things and seeing how they might relate to diabetes, heart disease, and obviously they have a relationship to cancer, because insulin and cancer also have some key mechanisms that are the same. Insulin being an anabolic hormone. We've been interested too in what diet may do in terms of cancer. And so that's really the three things. Diabetes, cardiovascular disease, and cancer are the sort of interests that one has in terms of diet, looking at mechanism.
Wow. Now, this is a very comprehensive story as to why this is your research interest. Would you say there was any sparking event during this path of finding the many interests that you have?
Well, I think there are many, many paths, and so many people have contributed that I'm only just reflecting the influences of people around me and the ideas. I mean, for example, Ruth the person who was from Toronto, but was doing her PhD in London with Stuart Trustful, came to our MRC unit, and I was discussing our work with them, and I was saying, look, this is how dietary fiber influences the effects of things in the stomach and the slowing of the stomach's emptying into the small intestine, the sort of things that may be happening there. Isn't that interesting? We can actually say that dietary fiber of certain sorts may reduce the rate, especially if it's sticky types of fiber. The pectins and beta-glucans in oats, things that make oats sticky. Those sort of fibers tend to slow the rate at which the stomach empties. And she said, well, no, that's not the interesting thing. The interesting thing is you can actually flatten the blood glucose curve afterwards. So wouldn't this be useful for diabetes? So yeah, we were not actually thinking of that point at this point, but that's quite correct. So that helped to push us in that particular direction of looking at those sorts of aspects. And that's eventually came up with the glycemic index on that. So those sort of things, there were lots of moments like that when people come and notice something that you think is very interesting and then interpret it differently. That's very interesting too, and that often gives you a completely different view.
For sure. And I think that's why it's important sometimes to have this interdisciplinary field.
Absolutely. And to also just discuss with people. It's not what you learn necessarily. It's how you discuss with people, I think, that stimulates interest in getting you to look further into something. If somebody just gives you a whole load of things or has a massive lecture with tons of things in the lectures you can hardly remember, that really isn't necessarily inspiring. Whereas if somebody comes along and says, look, this is how I think things work, and it's really quite simple. I mean, we were taught by Hans Krebs of the citric acid cycle, who got his Nobel Prize for the citric acid cycle. And when he used to teach us as students, he taught us in such a simple way that I have to say, half the class never came to the second lecture because they thought they could understand everything. No, those of us who stayed learned that there was a simple way of looking at things, which often gave you new ideas. And it's often when you reduced it to something simple that you get the new ideas. In fact, can I just digress for a few minutes?
For sure, yes.
If I can just digress on education, I was always worried because I was never a bright student, and I was pretty well hopeless at mathematics, and I wouldn't have been able to get into university if I hadn't had. It wasn't for a very tremendous guy who was my tutor, became my tutor in Oxford, who, when I went to an interview with him, he said, well, he had something very interesting under his microscope. He was looking at living cells with a phase contrast microscope, and you could watch them moving. I thought it was, and live. I thought, fantastic. And he said, do you want to have a look at it? And I said, yes, it's fantastic. And I was really impressed. And he seemed to pick up the fact that I was enthusiastic about science and work. And so he said, well, don't worry, when you come up, this is what will happen. And I said, well, I don't forget that, I've got to get in. I know I'll never get in. He said, don't worry, we'll make sure you get it in. And he did. He made sure I got in. But I think the important thing that I learned about this is that I don't think you have to be that bright to be a good scientist. I think it really helps. It's almost essential to be taught by people who are inspiring. Inspiring teachers are much more important if people get interested. And I got so upset about the fact that everyone had to pass exams and do all these sort of things, because I hated these exams. I hated having tons of tests and exams. And so I thought this must be a waste of time. So what we did is we looked at, over the last 300 years, since the age of the Enlightenment, we looked at the great medical innovators. We got together 100 top medical innovators over that 300-year period. And I got a group of undergraduates, in fact, to look, and graduate students who are going into medicine, to look at the CVs of each of these people and look at their young life and see whether they felt that they would pass the exams, MCAT, and all the other things kids have to do to get into med school, and pass the interview stage. And we came up with the results, which, when I talked to people, it was not so surprising, but it was quite surprising. There was statistically significant. Only about 25 people were bright. Only 25 people would, by current standards that all of you face today, would get into med school. 25% of 100 great innovators. 25% would be absolute failures. And 50% would be iffy. So our methods of selection by those standards can't be right. And we published it in the Quarterly Journal of Medicine.
This is a great lesson, because I think many students would agree that like tests and exams are always daunting and it's just anxiety inducing. So it's good to hear this.
Absolutely. And the fact they're not necessary makes me quite upset that we still keep on with this. Medicine really is not written in stone. It's constantly changing. And we need people not who've just learnt what's cast in stone, but are prepared to manipulate things and look at the data carefully as we go forward. And that's what it is, a case of looking at data.
For sure.
That's what medicine is.
And actually, I think this is a great segue into the next bit. We saw that you established a nutrition trialist network, so NTN. Could you elaborate what this is about?
This is a nutrition trialist network funded by the Nutrition Metabolism Institute of CIHR way back, and we're very grateful for the funding. It's allowed us to run studies across Canada, from British Columbia Laval, so UBC and Laval, and Winnipeg and Toronto in between, and look in large studies, because one of the big problems with nutrition is that we tend to have studies that maybe 20, if you've got 50 people, that's quite a lot in a nutritional study. If you've got 100 people in a nutrition study, you're doing well. But if you're looking at a drug study, you're looking perhaps at 6,000. So what we wanted to do is have a nutrition trialist network so we could run trials like the clinical trials you use for drugs, but the clinical trials now could be used for nutrition and looking at nutrition effects. Because it's interesting, you probably don't know nearly as much about what bread does to you as you do for the statin drug. And yet the statin drug is not taken by everybody. Perhaps it should be, but it's not. And bread is eaten quite regularly by everyone. So what I'm saying is we have very little knowledge about diet in the way that we do for drugs. So we felt this was a deficiency that should be stopped and corrected. And we were able to, we've been able to use that centre. We wanted to expand it, but there's been no further funding. So we'd like to do a lot more with the centre, but unfortunately the funding now has dried up. But we've run a number of studies, important studies through that, demonstrating the effect of diet in a clinical setting, which I think has been very useful.
So why would you say the sample size for diet and nutrition studies are so small?
Funding. And the fact that you need to be able to link up a number of centres, because if you just give a tablet out to someone, it's quite different than if you have to have dietitians and various people explaining to patients what they should be eating and what they shouldn't be eating. Then you perhaps got to give some of the food to them. So you've got to have someone to store food and someone to deliver food to them and get them to eat food. It's take a tablet. It's so much easier.
I see. Yes. And does participant commitment play into a role in this?
Oh, enormous. Yes, enormous. Absolutely enormous. We're very lucky that many of our participants have been tremendously responsible people. But I have to say that after you've been on a diet for about 3 months or 6 months or 9 months or a year, things slip, as you can imagine. So it is difficult. But I do think that you can make small and important changes in people's diets. It takes a little effort, but you can do it. And you also need to have the food industry behind you. And Health Canada have moved in the right direction too. I mean, they're advocating an interest in foods that prevent chronic disease, not just keep people growing, but actually prevent chronic disease, which is important. And that's why one of the reasons they've changed, both for that and for environmental reasons, to more plant-based diets. So Health Canada is now advocating more plant-based diets.
It's interesting to see when different parties outside of healthcare comes in and how that pushes things in a negative or positive way.
Absolutely. It is more prone to what's happening in the broader environment.
Yes, for sure. I'm going to zoom out of research and go back to you. So we noticed that you have a lot of academic degrees and qualifications. How would you say these have contributed to your perspective and approach on research, or just in general on what you plan to do?
I don't think my degrees have had a major impact on my research or me. I do think that the people that I've met while I've been doing these degrees have had a major impact. That is absolutely true. They've had a major impact. So I think I've been useful. It's been useful rather that I did degrees in human physiology. I moved as part of my medical course, and I had a good clinical exposure with interesting people doing clinical things. I did my research with a lot of very very important mentors who gave me ideas and who I could bounce my own ideas off. That was very valuable. So I think that the research trajectory was the important thing, not the degrees that one got. That was not important, but the people that one met on the way up. And that's why I'm actually, I feel I'm now qualified to say that I don't think exams are the major issue. I think the major issue is letting people have experience and looking at people who do interesting things. So if you decide when you're quite young to do interesting things or get yourself associated with the laboratory that's doing something interesting, that's what I think we should be focusing on in how you're selected for doing whatever else in life you do, not just by what grade you get. And that's my concern, is that exams end up being grades, and then the whole thing gets into a very formalized system, and it's rigid. And that's not what we need. I think we need to have flexibility and the ability to look over a broad range of things and make valid decisions. That's really what you need to learn.
Mm-hmm. That's such an important lesson. And it's like to not only learn from the books that you have, but rather from those around you, the networks, the resources.
Absolutely. By discussion with interesting people. If you find someone who's doing something interesting, see if you can have a word with them. They might spare you a few minutes. That's worth it.
Yes.
That'll be worth a lot more to you than just reading a book, really. And you'll have a lot of contextual memory of doing that.
Yeah, and I think that parallels really well with the goal of our podcast, to bring scientists and science closer to people so that they make use of it.
Absolutely. Yeah.
Okay, so is there any topics that you think you would like to or think is important to research or have studies done in the future?
Well, we've always been interested in diabetes, cardiovascular disease, and cancer. They still remain as perplexing in many respects, not in all, but in many respects, as they always were. There are always a lot of unknowns, and one keeps on coming across unknowns. Right now, one of the interesting things that we're looking at is something which is really essentially quite simple, and that is when you eat a meal. I'm still back to eating meals. When you eat a meal, then your blood pools in your gastrointestinal tract, and that's why your granny might have told you when you've had a big meal, you don't go out and go for a run or go for a swim, and that's because the blood is actually busy doing something else. Some people get this, if their nervous system doesn't compensate sufficiently for this, and the vascular system in legs and what have you doesn't constrict to allow the blood to then drain into the gastrointestinal tract, they get a big fall in blood pressure. So, as you can imagine, because the blood is taken from the systemic circulation and goes into the visceral circulation, back up to the liver. So they get a fall in systemic blood pressure, and it may cause fainting, may cause angina, may cause falls with fractures, which may kill older people. So we've been looking at that, and it seems to be that the change in the glycemic index of the food actually relates to that. So foods that are digested more rapidly, that give higher rises in blood glucose, tend in susceptible people to cause the fall in blood pressure. So we think that's interesting, because that may be another reason for choosing what we would call low glycemic index diets or low glycemic index foods, things like peas and beans and lentils and pasta and these sort of things. So those are sort of small things that we can do. The bigger things that we're trying to do is look at big cohort studies and see whether the sorts of therapies for which we seem to have risk factor reductions, whether the risk factor for heart disease or diabetes actually translates in the longer term to, if you have people who are reducing the diet, the impact of their diet in these particular areas. Does it make a difference long term to them in terms of health? And so we're very keen now in looking at what they call cohorts, prospective cohorts, where people have been looked at, as I mentioned at the beginning, a baseline and then followed, possibly with more follow-ups over time, but over a number of years, that can give one an idea on whether these people do better or do worse in terms of heart disease, diabetes, cancers, various sorts. That, I think, is a major interest that we've got and something we're trying to pursue, because it's not as good as the randomized controlled trial, no, but at least it's much longer, so that diseases that take a long time to develop, we can follow them and see whether they develop. So those sort of things are of particular interest to me right now.
That's amazing. These future directions kind of show how complex and connected, I guess, our system is, and how we function as a whole, not parts or pieces. Like, I feel like we often learn it as parts or pieces at school.
You do,
but
bits and pieces. Yeah, not the whole thing together, the integrative action.
Yes. And these future directions show that it needs to be integrated.
Yeah.
So that's a great
suggestion. That's why we're talking to people from different disciplines. I mean, that's where you've got more of the connections too. And in medicine, even people within different branches of medicine coming together and addressing a problem is good, because they're looking at the system, not just a part. Yeah,
for sure. The importance of interdisciplinary care and research comes up repetitively here. So, yeah. Okay, so one last question we have. We ask this to all of our guests. Do you have a favorite scientist? And if so, why?
Well, I've got many. I could tell you just quickly about two. I mentioned Dennis Burkitt, who was one of the pioneers of dietary fiber. That's why we've got fiber listed on the food packages today, is because of him. He, as he would say, he felt he was a failure, and he didn't think he'd get in, and certainly didn't think he'd pass his first year, but he did, very narrowly. He then went out to Africa as a medical missionary and treated people at Makerere University Hospital, and also worked with people in the countryside. And that's where he decided he never had to ask whether he could get a fecal sample from someone. He just said, go behind the screen, they'd pass it. And he realized that they were never constipated. And he noticed they never had any colon cancer either. So that he felt was dramatically interesting and important. And he also noticed, along with his colleague Hugh Trowell, a pediatrician, that they didn't see diabetes there, they didn't see heart disease. Even though they were teaching the Ugandan medical students, they taught them from Western textbooks, and they couldn't show them many of the things that Western textbooks had, because the people there just didn't have those diseases. So that's where the dietary fiber hypothesis came out, because he came to the conclusion that it's what came through the gut and went into the pot, as it were, that wasn't digested, that was part of food, but stayed undigested largely. And he saw that as dietary fiber, and that was interesting. And that's what started the whole fiber revolution. Well, that would have been enough for someone to have done in a lifetime. But he also noticed that there was a lymphoma that the children used to get. He thought about it, and he noticed that it was only really at a certain level. Once they lived in parts, say of the hilly parts and mountain parts, that were higher, they didn't get them. And then he realized this was the mosquito level. So he was the first person to identify a mosquito vector as being responsible for a tumor. And he came back to Britain and lectured. And the guy who finally ended up discussing viruses, he was a great virologist. And he identified the virus because he got Dennis Burkitt to fly samples back to the Middlesex Hospital and showed that it was a virus. And interestingly, he was therefore became that partnership that was an unusual one, a guy going to a student going to a lecture of a visitor who'd come from Uganda, and may not have happened, but did happen, and then going up and talking again to the lecturer after, said, look, I'm interested in what you're doing. Could we have some specimens and look for viruses by electron microscopy? And so these were flown back, and so amazingly, we've got a viral connection through an arthropod that infects children and causes a tumor. So really, he was the first person to identify, therefore, a viral cause of cancer, which bears his name, Burkitt's lymphoma. So he's sort of, I put him there in a class of his own. Then I would like to mention someone else who I think determines some other aspects that I think are important. Paul Ritker is currently a professor of epidemiology and cardiology at Harvard. And Paul thought that inflammation was probably one of the things that was related to chronic diseases of various sorts, and heart disease in particular, he thought. And he did lots of epidemiological work and lots of initial groundwork looking at anti-inflammatory drugs, and just looking at what they did in terms of cardiovascular prevention, looking at autoimmune diseases, and looking at the major trials for cardiovascular disease risk reduction, and showing that CRP reduction, that's an inflammatory biomarker, that if you could reduce this, in addition to cholesterol and all the things in blood pressure, all the things, if you could reduce that, you could probably get an increased reduction in cardiovascular risk. And everyone thought it was very interesting. But then he thought, well, I've got to show this, so he had to do it in a clinical trial. So he somehow managed an enormous amount of effort, raised a lot of money, multi-center trial, multi-million dollars, do you know what I mean? And did the Jupiter trial, where he took people who had normal blood pressure, normal cholesterol level, everything else normal, except they had a raised C-reactive protein level. He wouldn't normally treat these people. But what he did is he took these people, and the statin drugs also lower in inflammation, CRP, and he treated them with a statin drug and got a dramatic, even more dramatic than the usual group who raised cholesterol, a more dramatic reduction in heart disease when he reduced the CRP level. And so we all cheered when he presented at the American Heart Association meeting, everyone cheered. And then there was a sort of quietness after that. And what David Krzyzewski used to call the lipid mafia, what he meant was the people who believe that cholesterol is the only thing, or the major thing, that is responsible for heart disease. They said, well, look, you've still got a reduction in cholesterol. And one realized just how upset Paul must have been at this, that he'd done everything he could, and still he hadn't won. And what I think makes him probably one of the really great people in the field is that he didn't give up. He went on, and then he mounted one of the biggest studies, the most expensive studies in this area that's ever been undertaken. He got 10,000 people randomized in a clinical trial. But this time, he took an anti-inflammatory drug that would not affect their cholesterol level, that would not affect their blood pressure, which would have no other effect except to reduce the inflammatory biomarker C-reactive protein. And he gambled with this drug, and the drug costs were enormous. The cost of running a big study was enormous. In range, I think it was 5 years. At the end, wonderful, he got, with no change in anything else but C-reactive protein, he got a 20% reduction in heart disease in these people. Quite spectacular. But that wasn't the only thing he found. Incidentally, he found that cancer deaths were reduced dose response-wise, depending on the dose of the drug given. All I can say is that, that's the sort of persistence that I think one needs to show. Still doing big things, but being very persistent and consistent right the way through. And I think he's established it. We've all established it. Now we know it does probably cancer too, and a whole lot of things. it's opened the door tremendously to our thinking clinically. And so that's two different people. Paul, obviously very bright right at the beginning, but very persistent. Dennis, apparently not successful at the beginning, but very persistent too. Two very persistent. So the persistence is the thing that really identifies them, to my mind.
Yes, for sure, persistence.
So don't give up. Don't give up. That's the answer. Do not give up.
The curiosity as well, the courage that they needed.
Courage and persistence. And the ability to keep a steady nerve. Do you know what I mean?
Yes. Wow, these are two truly inspiring stories. And with that high end concludes our podcast. Thank you everyone for listening. If you found this podcast interesting, please keep an eye out for our next episodes and don't forget to subscribe to us on YouTube and follow us on social media.